Welcome to Mastering Solutions. In these, we're not asked to draw the ray diagram, so we'll just do the calculations for the position and the height like they ask for. To calculate the position, we can use the thin lens equation, of course. The thin lens equation says that the power of a lens is equal to 1 over the focal length, and that's also equal to 1 over the image distance plus 1 over the object distance. We're told that the object is 2 centimeters tall and it's in front of a 40 centimeter converging lens with a 20 centimeter focal length. So we have the image distance and the focal length, and we need to calculate the image position, which is S prime, of course. So 1 over S prime is equal to 1 over F, and we'll subtract over 1 over S, so minus 1 over the object distance. 1 over S prime is equal to 1 over the focal length, which we're told is a converging lens, so it'll be a positive value for F, and it has a 20 centimeter focal length, so 0.2 meters, and we're minusing the object distance, and so since it's in front or upstream of the lens, the 0.4 meters or the 40 centimeters will be a positive value here. 1 divided by 0.2 minus 1 divided by 0.4. So we have 2.5 diopters, and diopters are inverse meters, so if we take the reciprocal of that, 1 over 2.5 gives us 0.4 or 40 centimeters as our image distance. So that is S prime. Now we need to calculate the height. And this answer makes sense if you think about we're outside of the focal length, where the 20 centimeters is the focal length. If we were closer to the lens than this, then we would have a negative value here indicating a virtual image. Now, what are we going to use to figure out the height? We can use the magnification equation, which says that magnification is equal to the height of the image over the height of the object, which is equal to negative image distance over negative object distance. We're going to use this relationship right here. And the reason we're doing that is because now we calculated the image distance and we have the object distance. We have the object height and we need to figure out the image height. So that's the only unknown value for this section right here. So h prime over h is equal to negative s prime over s, and we want to isolate this, so we'll multiply both sides by h. So h prime, or the image height, gives us h times negative s prime over s. So we have h prime is equal to the height of the object, which we're told is 2 centimeters. So that's going to be 2 times 10 to the negative 2 meters. And then the image distance we found was 40 centimeters, or negative 0.4 meters. The negative is not from the answer, it's from the equation. And that's over the object distance, which is S. And we're told that the object distance is 40 centimeters in front of the lens. So we have 0.4. So this is negative 1. So looking at it in the calculator, we have 2 times 10 to the negative 2 for the centimeters. And then when we multiply this, we have negative 0.4 divided by 0.4, obviously is a negative 1. So we have a negative 0.02. So when we move this over to convert it to centimeters, we have 2 centimeters. And the negative indicates that it is inverted. And so we have a 2 centimeter tall image and a 2 centimeter tall object, and so the magnification is 1. We don't need that in this question, but just logically that's what's happening. It's the exact same size as the object, but since it's a real image, it's going to be inverted, which the negative indicates.